Dear students, welcome to the session. Today we are going to discuss parity generator and parity checker. First we'll see what is the purpose of parity generator and parity checker. Okay, the purpose of parity generator is it will generate parity bit at the transmission or at the transmitter. Right. Similarly, the purpose of parity checker is it will check the parity at receiver. Right. Purpose of parity generator is it will generate the parity bit at the transmitting end. Similarly, checker will check the parity bit at the receiving end. Now, what is this parity bit? What is the purpose of parity bit and why we need to check or why we need to generate this bit? The purpose of parity bit is it will identify the error when binary data is transferred or received. Right? The parity bit purpose is it will identify the error when the binary data is transferred or else when it is received. That's why we need to generate this parity bit and we need to check this parity bit value at the transmitter and receiving end. Right? Now, based on number of bits which are exists in binary data, the parity generators or checkers are classified into 3-bit parity generator or checker. Similarly, if binary data consists of 4 bits, then it will be 4-bit parity generator or checker. Okay. Now, the thing is, we need to design this 3-bit parity generator or checker as well as 4-bit parity generator as well as checker. And for this design purpose, there are two possibilities that the parity generator or checker can be done through either even parity scheme or odd parity scheme. So from this, if it is 3-bit parity generator, this generator we can design through even parity scheme or through odd parity scheme. Similarly, the 4-bit parity generator or checker also we can design through even parity scheme or odd parity scheme. Okay. Now we will design this 3-bit parity generator and checker, 4-bit parity generator and checker. Right. Now we will discuss 3-bit parity generator or checker design. As we know, to design a combinational circuit, first we require logic expression. Right? Logic expression is always obtained from truth table itself. So first I will develop the truth table, then by using K-map I will get the logic expression. Once you know the logic expression, then we can implement logic diagram. Okay. So first I will develop the truth table for this. right? As we are assuming it is 3 bit, so I am considering 3 input bits. A, B, C, right? And the output we need to generate a parity bit, right? So as I already told you, this 3-bit parity generator we can implement through either even parity scheme or odd parity scheme, right? So we can implement through either even parity or odd parity. First we'll develop the values, then we'll see the what is logic expression for this. Okay. As we are having 3 inputs, so 8 possible input combinations are possible. So I'll consider those are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. These are 8 possible input combinations. For all these input combinations, we need to find even parity bit as well as odd parity bit. Even parity is nothing but the total number of ones in this information, including parity, must be even. For a while, just see, in this, till now we don't have any 1. So I will put 0 here. Now I can say that the total number of ones in this information is even. Similarly, next, just see this one. Here, we need to make the total number of ones must be even, including parity bit. This is parity bit, right? So already we are having odd number of ones. So if I put 1 here, then you just see the total number of ones including parity is even. Means here we are having 2 ones. Means even number, right? Now here also we need to make this ones as a even. To make it even, put 1 here. In this, here already we are having 2 ones. Means even number. So I will put 0. So to make it 1 even, I put 1 here. To make it even, I will put 0. To make it even, I will put 0. Here we are having 3 ones. Means odd number of ones. So to make it even, I will put 1 here. So in this way, we can generate even parity bit. Now I will generate the odd parity bit. Okay? Odd parity bit. Odd parity is nothing but the total number of ones including parity must be odd. Just see, in this information we are having, we don't have any ones. So I will put 1 here. Now you just see, in this information including odd parity we have odd number of ones, that is 1. Now for this information, you just see, we are already having odd number of ones. So I will make this bit as 0 here. We are already having odd number of ones. So I will put 0. In this, we are having even number of ones, right? So as it is even, I will put 1 here. So the total number of ones in this case is odd. Similarly, here I am having already odd number of ones. So this value becomes 0. Here it is even number of ones, 2 ones. So I will put 1 here. Even number of ones. To make it odd, I will put 1 here. Odd number of ones are already there in your input. So I will put 0. In this way, we can develop the truth table for parity bit generator, the even parity scheme as well as odd parity scheme. Now I will design I'll find the logic expression for even parity scheme. To get the logic expression, we need to use K-map concept. As here we are having 3 inputs, so 8 possible combinations are there. So I am using 8 cell K-map with the inputs A, B, C. The values are 0 and 1. Each cell values, this is 0, 0, 0, 1, 1, 0 and 1, 1. Now, represent these output values in this K-map for each combination. So, for 0, 0, 0, the even parity scheme, output is 0. For 0, 0, 1, output is 1. For 0, 1, 0, output is 1. For 0, 1, 1, 0, 1, 1, output is 0. So for 1, 0, 0, output 1. 1, 0, 1, it is 0. For 1, 1, 0, 0. 1, 1, 1, we are having output as 1. So once the representation is over in K-map, then check for grouping. If ones are adjacent together, then we can make a grouping. As all are individual, so there is no possibility of grouping here. So I will consider this individual terms. This is first term. We'll take second term, third term, and this is fourth term. Now, the logic expression for this is what? I am considering SOP. So, sum of all terms will give the logic expression. Now, the first term value is what? For this first, A is uncomplemented form, so I can consider it as A bar, and B is complemented, A is complemented, and C is uncomplemented form, so I can write it as A bar, B bar, C. For the second term, this is A bar and BC bar. For the third term, we are having A and B and C are complemented form, so I can write A, B bar, C bar. For the fourth term, A and BC. We'll simplify this term by taking common values. We just see in these two terms, A bar is common, so I will take A bar as common, and it is B bar C plus BC bar. Right? In this, A is common, so we will get B bar C bar plus BC. Right? As we know, exclusive OR function is what? B bar C plus BC bar is nothing but exclusive OR. So I can write this as B exclusive OR with C. Similarly, this function is what? A B bar C bar plus BC, nothing but B exclusive NOR of C. Now, you can consider, you just see this B exclusive OR C, let us take as X. Okay. Then what is X complement? X complement is nothing but complement of B exclusive OR C, which is nothing but B exclusive NOR C. So I can write this as A bar X plus AX bar. So again this is exclusive OR function, right? So I can write this function as A exclusive OR X. But here X value is how much? A exclusive OR X value is nothing but B exclusive OR C. Right? Now we know the logic expression in even parity scheme. Once we know the logic expression, then we can develop a logic diagram. Right. As it is simply exclusive OR function, we know exclusive OR gate is having only two inputs. So first I will consider inputs are A and B. With exclusive OR gate, so A, B, we can generate A exclusive OR B function, right? Now I will take the third input C, which I given to one more exclusive OR circuit, then the overall expression becomes A exclusive OR, B exclusive OR, C. So in this way, we can generate even parity bit using parity generator. Now we'll see how can we develop or what is the logic diagram for odd parity. For odd parity scheme, right? As I have already developed the truth table, I'll consider K-map, 8 cell K-map to get the logic expression. Here the inputs are A, B, C. So each cell representation it is 0, 1. This is 0, 0, 0, 1, 1, 0, 1, 1. Now we just represent for each combination what is the output value in K-map. For 0, 0, 0 in odd parity scheme, output is 1. For 0, 0, 1 in odd parity scheme, output is 0. For 0, 1, 0, it is 0. For 0, 1, 1, 1. 1, 0, 0, it is 0. For 1, 0, 1, 1. 1, 1, 0, 1. And for triple 1, you will get output as 0. Again, as there is no 1 is adjacent together, I will consider single terms. So this is my first term. It takes second. This is third. And this one is fourth term. Right? I am considering SOP form here. So the logic expression is sum of all terms, that is 1 plus 2. Right. Now, here first term is what? For this output 1, you just see A is in complementary form and BC is also a complementary form. So I can write this A bar, B bar, C bar. Right. For the second term, A is complemented, so A bar, and BC is uncomplemented. For the third term, it is A and B bar, C. For the fourth term, A and it is BC bar. Right? Now we just check, is there any possibility of common terms? In these two terms, A bar is common, right? So take A bar as common and B bar, C bar plus BC plus, in these two terms, A is common, so take A as common and B bar C plus B C bar.